Have you ever gotten lost in a new city and wished you had a built-in GPS in your head? I am talking about the kind of navigation system that never fails and always shows you the exact path and the most efficient route, even if it is your very first time standing on those streets. Well, get ready to meet someone who not only has one, but whose version is like a spatial supercomputer straight out of a science fiction movie, complete with an unlimited hard drive for mental maps. Imagine this for a moment, like a friend telling you something that just blew their mind. There is a British artist named Stephen Wiltshire who possesses an ability that defies everything we thought we knew about memory and perception. Stephen has autism, and his mind operates in a way that challenges our understanding of the human brain. To witness his gift, you have to imagine him getting into a helicopter and flying over the vast, chaotic, and breathtaking expanse of a major metropolis. It could be London, New York, Tokyo, or Mexico City. During a brief flight of perhaps only 45 minutes, the entire city unfolds beneath his eyes in a sea of streets, buildings, bridges, and squares. He watches the coming and going of cars, the tiny details of facades, and the endless rows of windows. Then, he lands. He sits down in front of a gigantic canvas, which is sometimes up to 5 meters long, and suddenly, boom! He starts to draw. This is not just a simple sketch or a general impression of what he saw. What emerges from his mind and his hand is the entire city drawn from memory with such astonishing precision that it leaves you completely speechless. I am talking about every single skyscraper placed in its exact location. Every window is counted, and every architectural detail is faithfully replicated, right down to the specific number of floors in certain buildings. It is as if his brain had taken a panoramic, ultra-high-resolution photo where every single pixel is perfectly preserved, and he is now simply printing it on paper with a fidelity that rivals an official architect's blueprint. Do you remember when he drew the skyline of Rome with a whopping 4,000 buildings after just one helicopter ride? Or think about when he recreated the panorama of New York in that monumental 5-meter-long drawing, including details that even the locals who live there every day would overlook. Civil engineers and urban planners are routinely left open-mouthed by this level of accuracy. It is as if, instead of seeing a jumble of confusing structures like the rest of us do, his brain sees a complete technical diagram or a kind of holographic three-dimensional blueprint that he can then unfold in 2 dimensions. His spatial memory is so vivid and detailed that we are able to see the world through his eyes in a way that is normally unimaginable. This is where the mind begins to truly wonder how it is possible for a human being to store and replicate such a vast amount of spatial information with near-perfect fidelity. What kind of mental map is forming inside his head, and how does this internal GPS work that allows all of us to navigate the world, but which in people like Stephen seems to be turbocharged to levels that defy our comprehension? It makes us question the very limits of what is possible for the human brain. That is the million-dollar question that leads us to explore the most fascinating corners of our biology, including areas that remain uncharted territory for many. To understand Stephen and why his brain is so extraordinary, we first need to understand how our own brain's GPS works, even in its standard factory-fitted version that comes with each of us. We might not be able to draw entire cities from memory, but we all have an innate sense of direction. Think about it for a second. When you get up in the middle of the night in complete darkness, you still know exactly where the door is and where the fridge is in the kitchen. When you drive home after a long day, you follow the route almost without thinking, as if you are on autopilot. This is not magic, it is pure neuroscience silently working behind your forehead. Inside our brain, in a region with a name that sounds like a mythological creature, the hippocampus, we have special nerve cells that are vital to our survival. Scientists discovered these cells decades ago and called them place cells. You can imagine each of these cells as a small marker on a personal mental map. Every time you are in a specific place, whether it is your kitchen, your living room, or that park you always go to, a particular set of these place cells fires up. They are like lighthouse beacons, precisely indicating that you are here on your internal mental map. It is your brain mentally shouting that the location has been recorded. But the hippocampus is not a lone wolf, it is like the captain of a ship who needs its star navigators to function. This is where another key brain region comes into play, known as the entorhinal cortex. It was in this intriguing area that scientists discovered something even more astonishing, which even earned them a Nobel Prize in 2014. They found grid cells. These cells, instead of firing for a single location, create a kind of hexagonal, regular, and repeating pattern, like an invisible grid of cells covering all the space around us. You can visualize a Google Maps grid projected in 3D onto the real world, but inside your head. Every time you move, different combinations of these grid cells activate, helping you calculate distances and directions while understanding how one place relates to another within that space. They are, quite literally, your brain's coordinate system, allowing you to navigate and estimate distances without needing a measuring tape. Together, these wonderful cells form the foundation of our sophisticated internal GPS. They allow us to build a coherent and dynamic mental map of our environment, recall complex routes, and find our way back home without relying on a phone signal. It is an incredibly sophisticated biological system, perfected by evolution over millions of years, working tirelessly to orient us in space. Now, let's return to Stephen. If our internal GPS is a standard car with a very useful interactive map, his is a space rocket with X-ray vision, unlimited solid-state memory, and 8K recording capability. The explanation for his talent is not necessarily that he has more place cells or grid cells, but that his brain uses them, interacts with them, and processes the information it receives in a radically different and superhuman way. It is not a matter of quantity, but of a completely different quality of processing. Stephen is what we call a savant, a term that evokes admiration and mystery in equal measure. Savants are individuals, often with autism spectrum disorders, who possess extraordinary abilities in incredibly specific areas. This can include complex mathematics, perfect pitch music, or the ability to recall every book they have ever read. In Stephen's case, it is visual spatial memory and drawing at an absolute master level. It is not that they are geniuses at everything. In fact, they may have significant difficulties in other areas of daily life and social interaction. But in their field of expertise, their performance is simply mind-blowing, a true cerebral spectacle. This is where things get really interesting, and science becomes a thrilling detective investigation. The scientific community is still deciphering the exact mystery behind these abilities, but there are several key theories that bring us closer to the truth. One major idea is hyper-detailed visual processing without filters. For the vast majority of us, when we see a city from the air, our brain performs a kind of automatic data compression. It filters out what it deems irrelevant or redundant and retains only the general image and the key landmarks. It is like taking a low-resolution photo to save space and energy. Stephen's brain, however, seems to capture every minuscule detail, every window, every brick, and every crack, without any filtering whatsoever. It is as if he takes an ultra-high-resolution raw photo, one that contains every pixel and every shadow. It does not compress or interpret what it should see, it simply records the information in its purest and most complete form. Then there is his extreme photographic visual memory. It is not just that he sees the details, it is that he retains them with astonishing fidelity. His visual memory is so powerful that it has been compared to eidetic memory but taken to a monumental scale that encompasses entire landscapes. Imagine being able to replay that view of the city in your mind, on an internal screen with crystal clarity, as if watching a high-definition slow-motion video. He can then pause it at any point to draw every element with millimeter precision. His brain has incredibly direct and precise access to this massive visual database. Research using neuroimaging techniques suggests that in the brains of some savants, neural connections may be organized differently. In Stephen's case, it is speculated that the brain areas involved in visual and spatial processing, such as the posterior parietal lobe and the hippocampus, have exceptionally strong or atypical connectivity. It is as if the information superhighway between seeing, remembering, and drawing is much wider, with more lanes and no tolls, allowing for a massive and rapid data flow. Some studies have even shown increased activity or different wiring in certain regions of the right hemisphere, which is associated with spatial and creative abilities. Another particularly intriguing theory is proposed by Professor Alan Snyder, called the rule of absence. This suggests that sometimes the lack of one typical brain function can paradoxically open the door to excellence in another. Snyder proposes that savants might have unusual access to low-level or primitive information that we all have in our brains, but which is normally suppressed or filtered by our high-level cognitive processes like abstract reasoning or interpreting meanings. It is as if raw sensory information reaches their consciousness without the usual editor or translator that the rest of us use. For Stephen, this could mean that his brain does not interpret the city in terms of function or purpose. He doesn't look at a building and think that is a bank or that is an office. Instead, he simply records it in its purest form of patterns, shapes, lines, and textures. It is a fascinating perspective because it suggests his brain accesses a deeper, unprocessed database of reality. While it is a challenge to scan Stephen's mind while he is in the middle of his artistic work, studies on other savants using functional magnetic resonance imaging have revealed valuable clues. For example, different brain activity has been observed in the prefrontal cortex, which is the part of the brain associated with planning and abstract thought. In some savants, this area may be less active during their extraordinary tasks, suggesting that they perform these abilities in a more automatic or intuitive way. without the explicit cognitive load that it would entail for the rest of us. In Stephen's case, his drawings are not just exact replicas, they are undeniably artistically stunning. His mind does not just function like a high-end video camera, it also acts as an art director who decides the framing, perspective, and composition. This suggests an incredibly complex and harmonious interaction between his exceptional spatial memory and his innate artistic ability, taking the concept of mental mapping to a completely new dimension. The natural and hopeful question that arises is whether we could, in some way, unlock or cultivate those latent capacities in our own brains. The truth is that savant abilities are extremely rare and are often linked to very specific brain configurations that we do not fully understand yet. It is not something you can train in the same way you learn a language or how to play an instrument. However, studying individuals like Stephen Wiltshire is not just an exercise in wonder. It teaches us something profound and valuable about the unexplored potential of the human brain. It shows us that the way we see the world, process information, and remember things is not the only way possible. It forces us to reconsider how flexible and surprisingly capable our neural networks truly are. Although not all of us can expect to draw entire cities from memory after a short helicopter ride, the fundamental principles of our brain's GPS are universal. Stephen's ability reminds us that, even with similar neural hardware, the individual configuration can lead to results that expand our conception of what is possible. Stephen Wiltshire's story is a living testament to the incredible diversity and endless mystery within the human brain. It pushes us to the limits of our understanding, making us question what memory, perception, and talent truly are. His existence tells us that there are still vast territories to explore within our own heads, secret chambers of potential that we have only just begun to glimpse. Every time we marvel at one of his drawings, we are glimpsing a different brain function and a unique way of encoding reality. That is one of the most amazing things we can learn about the hidden codes of our own brain. Who knows what other maps are waiting to be discovered in the minds of others? If you enjoyed this deep dive into the human mind, don't forget to subscribe to the channel. For more information, visit minrora.com.